it احتمالات احتمالنا in Pashto. But before probabilities, we should study some basic concepts about probability, which one of them is counting principles. We have different counting principles in our daily life or in mathematics. For example, if I say to you that there are 5 chairs and 5 tables in this class, how many total objects are there in this class? You will add the number of chairs and the number of tables. In this case, you will say that totally we have 10 objects in this class. Or if I ask you that how many different 3-letter words we can make from A, B, C, 3 different letters. So in this case, you should use a different way or different method to count how many different 3 letters words we can make from letters A, B, C. Or like this. These are counting principles that we can use or we use it in our daily life. One of them, as I said to you, that it's an addition principle. If we have 2 different actions that they cannot be performed or done at the same time, in this case we use addition principle. For example, as you see on the board or on the screen, the example, Mary has 3 different Barbie dolls and 2 different Cindy dolls. If she has only the choice to take one of these dolls, in this case, how many different choices are there for Mary? So you should add the number of choices, which she has 3 choices for Barbie dolls and 2 choices for Cindy dolls. So the total choices 3 plus 2 is 5 in this case. And each choice or each element in this for this choice is called what? Outcome. Or if I call each choice as D1, D2, D3, D4, D5, so each element of these, each element of this set, as I wrote it as set, is outcome. This is one way of principle. The other way is listing method. For example, if I say to you that how many different choices are there if I roll a dice, so there are 6 different choices, which one of them is 1, 2, 3, 4, 5, 6, 6 different choices. We have different methods for listing also. One of them is simple listing. For example, example of listing, simple listing. David wants to buy a shirt. There are 4 different color shirts in David's size. So how many different choices are there that David buy these shirts? I think there are 4 because there are 4 different colored shirts for David that he can buy them. So this is simple listing. Or if we define it, if our task contains only one part, in this case we use simple listing. As we gave an example in here, in this example that we said for buying a shirt or for buying a shirt by David, there are 4 different color shirts, so he has 4 different choices to buy the shirts. The second type of listing is using a product table. As in previous type, we said that if our task contains one part, for example, choosing one type of the shirt, which it has 4 different colors. But if our task contains 2 parts, for example, in this example, Salim needs to go into and out of the library. If the library has 2 doors, in here it has 2 doors. We have 2 different choices in this case. What should we do in this case? In this case, we can use product table for simple examples or for simple problems. So, for example, two doors in here. Now we have two choices to go in to library, and we have two choices to go out from the same library. If we call each door as A and B, so he can enter from A and go out from A again. He can enter from A and go out from B. He can enter from door B and go out from A. He can enter from door B and go out from door B also. So in this case, we can use these types of tables. Or, for example, in this example, let me explain it. How many two letters word we can form by using A, B, C, these three letters, two-letter words. For example, we can combine A with A, we can combine A with B, or A with C, for example. We have three different choices for first letter and three different choices for a second letter, as you see in this table. So in this case, we have 3 times 3, 9 different choices for this example. Again, we can use product table, but in some cases, it's a little complicated. For example, in previous example, we have two choices and two choices for going in and going out. Or for first letter, we have three choices. For second letter, we have also three choices. So we multiply 3 by 3. But let's generalize it. In this case, we use multiplication principle. In some cases, the number of outcomes or listing the number of outcomes or all outcomes may be a little unnecessary, or maybe it's a little difficult. So we cannot use the product table or listing method. So we should use multiplication principle in this case. But for multiplication principle, it's necessary that for each choice that we have, the probability or the possibility for each choice must be equal for each choice. Or for these types of tasks, which each part has the same choice, we say that it satisfies the uniformity criterion. If a task or a problem satisfy the uniformity in the criterion, so in this case we can use multiplication principle that we will see in some examples in next lesson. But how can we calculate the number of possible ways to do or to perform a task? Or how can we calculate the number of choices using multiplication principle? Suppose that our task or our problem has k parts, and each part or first part can be done by n1, second part can be done by n2 ways, third part can be done by n3 ways, and so on. In this case, the total number of ways that we can do, or choices that we can perform our task, is n1 times n2 times n3 times and so on up to nk. It means we multiply all number of ways which we can do each part of the problem, and we will find the total number of ways which we can do the task. For example, Nicole has 4 different skirts, 3 different blouses, and 2 pairs of shoes which she can wear for a business meeting. In how many ways can Nicole dress for the meeting? If we say the choices for skirts as S1, S2, S3, and S4, it means the total number of choices is 4 for skirts, and the choices for blouses are 3. We call it as B1, B2, and B3, which there are 3 choices for blues. And for shoes, we can say as a C1 and C2, because he has 2 choices for shoes. So the total number of dressing or types of dressing which she can do it for that meeting is 4 times 3 times 2 is equal to 24. Uh, it means that she can dress for that meeting 24 different types. Uh, it can be in S1 with B2 and C1. It can be in S2, B2 and C1, or S3, B1, C1, and different choices she can dress for that meeting. Next example, how many different two-digit numbers can be formed using the digits in the set 1, 2, 3, 4, 5? It means from these 5 digits, how many different two-digit numbers we can form. For example, if we call the two-digit numbers, or if we say the two-digit number as digit 10 and digit 1 unit, I'm sorry, this is a 10 digit and this is a unit digit. So in this case, how many different choices do we have for 10 digits? As we have 5 different digits, so we have 5 choices or 5 ways for 10 digits. So 5 times how many different choices we have for unit digit? We also have again 5. So 5 times 5, 25. 25 different two-digit numbers we can make using 1, 2, 3, 4, 5. For example, one of them is 1, 1, 11. It means 12, 13, and so on. Or, for example, 21, 22, 23, like this. Or, for example, 31, 32, 33, and so on. If you count all of them, you will get that you will see that we have 25 different two-digit numbers which are formed by 1, 2, 3, 4, 5 digits. Next example, which is related to previous example. In the previous example, how many numbers can be formed if the digit cannot be used twice in a number? Again, for 10 digits, I'm sorry, for 10 digits, we have how many choices, and for unit digit, how many choices do we have? If we use one of these 5 digits, so we can use, or we have 5 different choices for 10 digits. But the question says, or the problem says, that the second or the same digit cannot be used twice. So how many choices will be left for unit digit? Because we have the total number of digits are 5. So one of them are used for 10. So 4 choices are left for unit digits. In this case, 4 times 5 is equal to 20. We can form 20 different two-digit numbers if we don't use the digits twice, one of the digits twice. As you seen here in previous example, this 11, 22, 33, 44, and 55. If you see the total number of digits, the total number of two-digit numbers which we can form at 25, and 5 of these two-digit numbers are numbers with the digit is used twice. So if we subtract it from 25, we will get 20. It means 20 numbers, two-digit numbers, which are formed by these 5 digits, and 20 numbers, the digits are not used twice. Next example, in a particular city, all the telephone numbers are 5-digit numbers which start with 4 or 5. It means for first digit we have 2 different choices, or 2 different ways are there for first digit, 4 or 5. The 2 and 9 buttons on Mahmoud's telephone do not work. It means we have totally 10 digits, but 2 of them, which are 2 and 9, are not working. So the remaining digits are 8 digits which Mahmoud can use them on his phone. How many phone numbers in the city can Mahmoud dial on his phone if digits can be repeated? Second case, if digits cannot be repeated. Again, we have 5-digit numbers, so let's write the first digit, second digit, third, fourth, five. First one, second one, third one, fourth one, and fifth digit. So for first digit, as it's mentioned in the question, we can use only 4 or 5. It means we have two choices for this one. Times for second one, for first case, A case, digits can be repeated, but in Mahmoud phone, 2 and 9 buttons are not working, so it means he can use 8 digits. The digit can be repeated. It can be also 4 or 5, which we use it for first digit. So 8 choices he can use for second digit. And also for third digits, he also can use the 8 other digits except 2 and 9, which are not working. For fourth, he can also use it 8 and 9, 8 digits except 2 and 9. Again, for fifth digit, he can also use the 8 other digits. So the total number which Mahmoud can dial from his phone for first case, I mean if digits can be repeated, is 2 times 8 times 8 times 8 times 8. For first digit, he has two choices, second 8, third 8, fourth 8, and fifth 8. But for second case, if digits cannot be repeated, again, for first digit, second, third, fourth, and fifth. For first digits, he can use two choices, 4 or 5. So he has two choices for first digit. But for second one, if he use 4 or 5, one of them, so for second digit, he has 7, because first digit cannot be repeated. 4 or 5, one of them cannot be repeated. So he has 7 choices for second digit. Let me write the number of digits also. For third one, has he used another digit for second one? So one is also decreasing. So in this case, he can use 6 different digits for third one. For fourth one is also another digit is also decreasing. So he can use 5 digits. Or for fifth one, there are 4 digits will be left that he can use it for fifth digit. So the total number of numbers which he can dial it is 2 times, 7 times, 6 times, 5 times, 4. This is the total number of digits that Mahmoud can dial for second case if digits cannot be repeated. For first digit, he has 2 choices, 4 or 5. For second digit, as he used 4 or 5, and the total digits which are working in his phone is 8, so 1 is used in here, so 7 left. For third one, 6 are left. For fourth one, 5 are left. And for fifth one, 4 digits left, which or 4 choices are left, which he can do it, or he can use it. This was our lesson for today, counting principle, which is the basic concept or basic subject for probabilities or statistics, which we will use them for studying or for learning probability. So for today our lesson is enough, and we will continue a new subject for next week, which is permutation. Permutation is also a new lesson for probability. Thank you.